For the benefit of anyone who is new to the channel, I'll just quickly talk about some of my processes for staying organised while I'm dismantling something like this. I tend to have various colours of Sharpie around. That allows me to colour code connectors and headers. That's the usually white plastic plugs and sockets that may be used to connect different boards to each other, boards to switches and so on. Sometimes what you'll find on a build is there are more than one socket which is the same size, type and has the same number of pins on it. So it's possible to connect things wrongly when you reassemble. Having those similarly sized connectors, different colours with Sharpie pen will help you avoid those sorts of pitfalls. Almost anything like this is going to have at least 2 or 3 different sizes of screw or other fasteners, and some builds have had 10 or 12 different kinds. You could use multi-compartment boxes or ice cream tubs or jars, things like that to keep organised. What I've taken to doing is getting a bunch of little bags like this. What I can then do is take some masking tape, attaching that to the bag and then writing on the bag where it came from, and that way I'm less likely to plug the wrong screw into the wrong hole. You can also use Sharpie to write directly onto the boards. For metal parts, you can usually write on that with an HB pencil. I try and make my teardown videos as thorough as possible, so you will have some sort of reference footage to look at, but it's also wise to take some photographs as you go along. I'm going to begin taking this apart in the order suggested in the service manual, which is by taking this door off. So we press eject like that, and then there are 2 plastic clips, one on this side and one on this side. There's kind of L shaped and going into recesses here and here. So if I push inwards on those, that door's just going to lift out like so. In case on your unit these have fallen off, just note that there is a little plastic spring part here and a spring here as well, and these are held on with metal retainer clips. I'm not going to remove those because it looks like the plastic has been melted slightly to hold those in place, and I don't really want to have to do any plastic work on this when it's not necessary. I've just removed 6 screws from the bottom surface. 1, 2, 3, 4, 5 of these are identical, and we've got one of a different type that goes into this hole here. It doesn't specify in the service manual what the screw head type is. Could be Japanese industry standard, but I've used a Phillips head screwdriver and it worked just fine. These 5 screws, you can see they're maybe 55, 60 millimeters in length. First 20 millimeters of which has a thread on it. Pitch, that is the space between the thread, quite wide, which indicates to me that these are going to go into plastic mounting posts. The other screw is significantly smaller, it's about 10 millimeters in length, and the thread goes over the entire length. Pitch is narrower and the angle of the thread is shallower, which indicates that it's going to go into a metal surface. Here on the same surface as the battery compartment, I've removed 2 screws. Again, they're about 10 millimeters in length and appear to be going into metal. However, these are countersunk, meaning they have this little angled area so that they're flush with that surface. With those 8 screws removed, this entire plastic part, which is sort of L-shaped coming around the corner here, come away. You can see that there's a wire here which is firmly attached to this shielding on this part of the case underneath this bit of tape here. The connection here is soldered on. You can see that it's very close to the corner of this plastic part. Just for my convenience, I am going to desolder that. It's a pity in a way that there isn't some sort of connector or something there. On a lot of Tascam builds, that would be a header and connector. If you don't have soldering skills and you just want to change the belts on this, it would be possible to leave that attached, but I imagine it's going to become awkward to have this flapping around. My soldering iron is at 350 degrees Celsius. I find that's a good all-round temperature. I find that by introducing a little bit of fresh solder, the rosin in that helps something like that to detach. So I will use a little spot of desoldering braid to get the last of that solder off that pin. And some more fresh solder in preparation for that being reattached on reassembly. There are 3 fixings accessible through this bottom printed circuit board that we need to detach in order to get the case on the opposite side off. In this hole here, we have a crosshead screw. I used a Phillips screwdriver to get that out. It's maybe 12 millimeters in length. The pitch and angle of the thread suggests this was going into a plastic mounting post. In this hole here, we have this extender, which I got out with a flathead screwdriver. And in this hole here, I have this extender, which again I got out with a flathead screwdriver. One little pitfall here that I've fallen into, that I hope I can help you to avoid, is do not unscrew crosshead fastening that's available through this hole. I'm not exactly sure what it is. I think it might be the thrust tension for one of the flywheels. But anyway, that's rolled off into the timbers of the unit and we'll find it later on. But it's only these three holes and not that one that we want to be dealing with. Now if we flip this over, this front section will slide out. Notice that the speaker is attached and the cables are held down with a little cable tidy there. So we'll want to put those cables back around this little winding when we reassemble this. Again, these are soldered in. It would be great if there was a connector there. There isn't. I suppose we could leave that dangling off to the side. I think that's quite inconvenient, so I am going to desolder those. Notice that from this perspective, the black cable is going to the leftmost of these two terminals and the white is going to the rightmost. If you wired them in the other way, it would just mean that the phase of the AC audio was flipped. Again, I'm adding a little bit of fresh solder to make these joints a little bit more compliant. You could just pull them out like that, but look, that's a bit messy, isn't it? Solder splattering everywhere. Probably what I should have done is desolder that a bit first. And I can pull that away without any splatter. With that desoldered, we can take this top piece of plastic with the speaker attached via 3 crosshead screws and put it to one side. In case it's helpful for you, notice that there is a metal fixing here with a tension spring attached to it in this corner. That's what it looks like from the other side. I assume that's something to do with the tension of the door. And you know what, for the sake of being able to clean this plastic more easily without risk of getting any moisture onto the speaker, I will just quickly detach that. So we have 3 identical screws here. They're going into plastic mounting posts, so the pitch is wide, the angle is shallow. They're about 10 millimeters long and pretty different from any of the screws that we've looked at so far. Beneath them there are these metal clips. This little indent on them faces away from the speaker, and this part with a V faces toward the speaker. The speaker was situated with the terminals close to the bottom here. So that gives us a slightly better access for cleaning of the plastic, because it does look a little bit dusty. Just going to pause the deconstruction here and comment a little bit on what's visible now that this mechanism and circuit is exposed. I'll just talk about what looks familiar or unfamiliar to me, going from the top left down to the top right. Speaking as somebody who's never serviced one of these before, but regularly services Tesco and Portastudios and the like. So we can see there's a transformer here. This will be converting the 240 volts input into 6 volts usable by the rest of the system. I know it's 6 volts because there was the 6 volt input for the recharging of the battery. I assume it's running on 6 volts and not on the 12 volts that we see in Portastudios in order to be able to take battery power from this battery compartment here. There's a slow blow fuse here. It says 1.25 amps. Below here is the circuit board. I imagine this is mainly to do with the recording and playback, though these larger capacitors that are visible are probably to do with filtering of the rectified AC voltage that's coming from the secondary side of the transformer. Moving over, we can see a mechanical counter here that's driven by 2 belts which seem pretty loose and in need of replacement. So we can see that when this supply reel turns, that rotation is turning this double-ended pulley, which is turning this extremely loose belt, which is still just about turning this counter. And then when we press this button, the counter resets. Over here we have the raise head, and this is both the record head on the left and the playback head combined into one unit there. It's the half of the tape closer to me that has apertures on the head. The further side, that would be side B if we're thinking of a cassette of having a side A and a side B, is not subject to record, erase or playback. Although I'm not sure whether Marantz ever made a unit which used half of the width of the tape for one part of a stereo signal and half for the other. They certainly made units where the whole width of the tape was recorded, and from the point of view of dynamic range you will get a better fidelity from those recorders, and more so again for recorders like PMD 222, which will do a higher tape speed as well as the standard one. Here we've got the pinch roller that will raise and touch this capstan pin, pulling the tape over the heads at a steady speed. And then here we have the take-up reel. This mechanism here will be to do with detecting whether this has reached the end of the tape or not. When this stops moving, this will trigger the full stop that was advertised on the top of the case of the unit. I'm trying to figure out how this detects whether there's a cassette present. It seems like I can't press play without the unit turned on. But if I could, then this whole array will raise so that the pinch roller touches the capstan and these two heads rise up into the shell of the cassette. This switch here detects whether the record tab is present on your cassette, so you can protect master recordings by removing that plastic tab. If that switch connected to that plastic lever doesn't close, the unit won't record. Here we've got more electronics, which I guess is just to do with the line outputs and so on there. That's about all I can see or comment on at the moment. Moving on to this front panel, you can see that I've already begun to remove these plastic knobs. For that, I'm using a spudging tool. A spudging tool is ordinarily used for the removal of car upholstery, but you can get a plastic set of things like this for not very much money off marketplaces like Amazon. In the case of these switches, there is a chance that it's going to ping like that, but they come off basically pretty easily. These two, however, especially this one on the right, were very difficult to get off. It took me a couple of minutes to slowly pry this off. I'm just working around till it came off, but it was very stiff. There are 4 holes for screws, 2 on this side and 2 on this side. I'll cut in some handheld footage of me pointing out exactly where those holes are. The screws that came from there are maybe 7 or 8 millimeters long and countersunk. They're identical to each other, but they're completely different to any of the other screws that we've looked at so far. With all those knob caps and screws out the way, I'm going to tip this forward and up. Just give it a little bit of a wiggle, because these plastic parts are slotting into spaces here and here. So you can see that this dual meter just dangles in that position really. There's nothing fastening it there apart from the pressure of this plastic plate on the front. And we have some dust collectors behind these switches. I'm going to leave them in situ because I can't quite see from this angle whether they're glued on. I don't want to disturb the glue. On this unit, it looks as though this battery check switch is a little bit broken. Now, I hope that didn't happen as I was removing that front case, but let's be aware of that potential pitfall. We want to maybe push that in a little bit as we lift this up so that that part doesn't catch against there. As I was filming the teardown, I forgot to mention some of the fixings on this front panel, so I'm shooting this out of sequence. This pot here is attached to this bracket via a nut and thread. The nut, I think that was an 11mm socket that I used to remove that. Likewise, this nut here. This bracket is also attached to the plastic chassis via 2 countersunk screws. They look like that, removed, about 5mm long. They're machined, they have no pointed tip. The battery check switch and the mic attenuation switch are both held in place with a single screw. We need a smaller crosshead or JIS screwdriver for that. This is what the screw looks like, maybe 7mm in length. And then these 2 microphone input sockets are held in place with, I don't know if we would call it a nut, but certainly it's threaded and threads onto this black plastic thread. I found that quite difficult to remove. I used 2 flathead screwdrivers to untighten it. The next thing it says to remove in the service manual is this PW board. It turns out we do need to peel back these little felt dust protectors a little bit in order to access 5 holes along the front here for these little 1, 2, 3, 4, 5 screws. I'll cut in some footage showing the exact location of those screws. Those screws are not much more than 5mm long. They're countersunk. The narrow pitch, shallow angle of them shows that they're going into metal housing. They aren't the same as any of the other screws we've seen before. They have a crosshead. I used a Phillips screwdriver to remove them. We also have 1, 2, 3 locations where we removed this kind of screw. It's this kind of head on them. They're about 12mm long. Continuing to work towards getting this tape player out so we can change any belts and so on. I've unscrewed this nut and released this washer from the socket here. I used a 14mm socket, but you could just as easily use a pair of pliers. Then there's 4 screws that we need to remove. One of them is just off to the side of the motor, and it's down in this space here. The next one is here where I'm pointing with my finger. The next is here. Notice there's also a ring connector to ground there. And the last one is pretty difficult to see. You're going to have to remove this black tape, which in my model at least is doing a bit of tidy up, keeping this bundle of cables glued up to this battery compartment here. Where I'm pointing with my finger, there's a screw. The other three are all of the same length. They're like this. They're going into plastic mounting posts, maybe 12mm in length. The one in this position is longer. It's 15mm in length. With those screws removed, we need to take this piece of metal off the top of this socket. It should wiggle out, and then there's another piece of metal underneath there. It looks like that. You can see it's got some tape and some shrink wrap on it to stop it shorting out against any of the neighbouring components. With all that removed, this is loose. I'm going to try and establish now how we can get it out altogether. I think I'm probably going to have to cut some of these cable ties that are tidying these wires. You can see that the cables that are going to this socket are tied to cables that are going down to these line out sockets. So just carefully with this sharp pair of scissors, cutting those without cutting the cables. I'm also going to cut this one here. Bit more leeway now. There's a connector here I can detach. I'll hold that against my skin so you can see the contrast better. 6 pins. The connector at this end is of the type where we pull these little plastic parts out the way so that those will detach. And there's a slot and groove there so you can't turn it around 180 degrees. So there's a cable going to circuit ground here. So I'm going to unscrew this screw as well. That screw I just removed is of the same kind that we removed from 3 of these locations. Now we can just about get this turned over. I can see that the capstan belt is turned to tar. These orange and black cables here are terminating on a black header just in there. You won't be able to see it because it's dark. And there's another connector just underneath these boards. It's attached to this board in the bottom. There is a little release tab. I wonder if you can see that there. I realise the light's not great, but if I push on that, then that becomes detached from there. And that's it coming out of that space there. As you may be able to tell, we're now at a point in the deconstruction where I don't have good guidance from the service manual, so I'm figuring things out. The easier way to be able to see where various cables are plugging in down here is to detach this little module which has the line outs, the DIN socket, the speaker outs, etc. That is actually clipped into place here by this finger. You can see there is a rigid part with a lip, and then we have a flexible, well, somewhat flexible clip here. So what I did was put a flat head screwdriver in there, pry that backward and push on the surface through this cavity. That was sat in there and came out from the back like so. With that out of the way, now we can see the first socket I detached is down here, the second one was here, then this third and final one, brown and grey. If I pull on that clip, that releases that and I can pull it out. Overall, this design is not very modular. I'm used to working with designs where at one end of a cable there will be a easily detachable and reattachable connector and header, whereas most of the connections on this appear to be wired in at both ends. But we now have the ability to move this transport around a bit, gain access to the belts, clean mechanisms, clean the pinch roller, clean the tape path, this kind of thing. I'm not convinced that there's a really good way to set up a tripod to show this. It's kind of crazy to me that they haven't made some of these wires detachable. This, without desoldering things, is about as far as you would get. And you can see that even the connections to the battery wired in, so you can't even get this free from this, which is what I was hoping for. So I'll try and talk about the fastenings that were disconnected to get to that. There aren't actually that many of them. So this transformer went into this space. There's 2 screw holes there, and these are the screws that went into them. Narrow pitch because they're going into this metal plate below. This brass plate houses speaker on-off switch, the mains inlet, and the DC inlet. It was sat with this hole corresponding to this mounting post, and this hole corresponding to this mounting post. This hole had this screw and this little cable tidy in it, and that's what we saw holding down the speaker cables earlier in the video. This mounting post here corresponds to this hole, and that was attached with this spacer with a screw in it. So that would be sat like that, okay, this part underneath it, and then that hole in the spacer corresponds to this hole in the bottom left of this daughter board that has the slow blow fuse in it. So there's a smaller intermetal screw that goes into there, like that. Notice that it's similar to, but shorter than, the screws that are being used to attach the transformer to this base here. The other corner of this daughter board corresponds to this mounting post here, and that's using this widely pitched screw because it's going into plastic. The final screw pertains to this hole here, and this tiny little daughter board with one hole in it and one big resistor. So the order I removed them was this one, then these two screws, then this lower part of this contraption here, and this screw with the cable tidy on it there. I did have to cut two cable ties which were grouping some of these thick wires going to and from the transformer. I think they were just in two clumps, one like that and one like that. There just wasn't enough give to get this out of the way without cutting those. At that point, all I did was kind of work all the various wires through this compartment and this compartment of the plastic chassis in order to get this mess. It looks like a dog's dinner, but actually there wasn't that much work to get it that free, which isn't very free. But that's about as much access as we are going to get to replace capacitors or integrated circuits or semiconductors if we had to do any electrical troubleshooting. I do sincerely hope that I don't have to, and all I'm going to really need to do is give this a good clean and lubricate and change the belts. Visually, this doesn't look all that bad. I hope by just applying a little bit of silicone spray lube judiciously. That is nowhere near the tape parts, nowhere near any parts that actually rely on friction to work. Clean and demagnetize the heads, blow any dust out with compressed air, clean the plastics. I will show you how to remove the pinch roller. I'll just wait until the belts have arrived to do that so we can clean that, or if we needed to replace it. And then I'll reassemble it. Hopefully it'll be okay. This looks like a very large-scale version of the GEC transport that appears in a lot of Tascam Portastudios, which would be faint praise, except I think the scale up, the chunkiness of it, the increased size of any springs, the fact that it's got dual flywheels, all of these suggest that this is going to be a more stable and reliable version of the same thing. The belt kit has arrived. So it's come from this place, webspareparts.com. It's a little pamphlet that's come with it, so it looks like they sell a lot of stuff for turntables, cassette decks, reel-to-reel belts, etc, etc. They're based in the EU, so if that's close to you, you could go there. I'm going to measure these for those of you who want to try and use belts from a multi-pack or something. So the longest one here, folded length, is about 140, maybe 145 millimeters. Next longest, that's 100 millimeters. I think these two are the same. No, maybe one slightly longer than the other. The longer one, 90 millimeters. This one I guess is going to be maybe 85. Yeah, 85. The shortest here, it would say 65 millimeter in folded length. So let me just check the width of these. So the thickest is maybe 1.5 millimeter, and the rest of them are 1 millimeter thick. I've fitted the belts now. I can only find locations for 4 belts. I've gone to the service manual, checked the parts list, and checked the exploded views, and I can only see 4 belts. So I'm not quite sure why we've been provided with 5. In order to fit these 2 belts, I had to remove this plate. And there's 3 kinds of screw that are going into that. This countersunk one, which is maybe 12 millimeters in length, it came from this hole here. This hole at the top, you can see the shaft of it is quite a bit thinner. It's about 8 millimeters in length. And then from this hole here, I have this screw, which is about 12 millimeters in length. Notice that these 2 countersunk ones, we'll put the longest of those belts on first wrapping it into the indent on this flywheel. And then this wants to go against this edge of this flywheel and around the lower of 2 slots on this pulley. Then the second longest one of those in the pack fits over the top like that. Up on this surface, take these belts off first of all. The second shortest, you would wrap around this pulley beneath the counter, and from there onto the lower of these two pulleys on this white plastic part that's just off to the left of that supply reel. And the second shortest one that was provided, fits over here. Should you need to replace or clean the pinch roller, here's how you do it. Get something metal into that space to pull off on this C-clip. Lift up. Now, as this comes off, notice the position of the spring. This part is going into this slot here. To get this out, usually if we just push back and forth using needle nose pliers, at some point it's going to come out enough from one end to be able to pull it out. There we go. So push that through and I can just pull it out. The overall diameter of that is 12 millimeters, 9 millimeters. The rubber itself, 6.5 or 7 millimeters there. Central pin is 2 millimeters. You can see there's some dirt on there, but it's not decomposing in any way, so I will dip that in MG Chemicals Rubber Renew, give it a good wipe against the paper towel and reinstall it. With the benefit of hindsight, it would have been great if I'd actually tried to plug this in and get some sort of baseline for how this was behaving before I did all this. But unfortunately I didn't, and the problem that I'm encountering now is that when I plug this in, either using DC jack or the AC power inlet, I'm not getting any response from the meter. I'm not hearing any hiss in the line outs or the headphone out. And when I test with a meter, although there are AC voltages appearing in this transformer part of the circuit, I'm not getting DC voltages on the base of any of the integrated circuits. I'm also increasingly suspicious of the fact that the play and record buttons will not go down at all, regardless of whether or not there's a cassette in it, regardless of whether this record tab detector lever is depressed or not. So what I'm anticipating at the moment is possibly I have to troubleshoot the power inlet for the circuitry, and possibly I have to completely disassemble and reassemble this cassette player in order to understand whether and how it's jammed, which would give me a sinking feeling even if I were doing this for myself on a unit that I was able to completely disassemble. But on a unit where everything is attached in one sprawling mess, no matter what you do, where I'm meant to be charging the client for my time, we may have reached the point where this is beyond economic repair. And at this point I need to speak to him to find out how much this owes him, how set he is on having this working again. Probably going to offer not to charge him for any of the time that I've put into this, since I've got YouTube footage out of it, and it's useful for me to know to avoid this in future because of some of the build issues around it. Thanks for watching. Hope to see you again soon.